developing next-generation research and technology, facilitating connections between AFRL industry and academia, unlocking innovation through a culture of collaboration. This is the AFRL Regional Network Midwest.
This project is the laser welding in space project that we have going on. It's got a retrofitted vacuum chamber that we've put a 1 kilowatt laser onto in order to simulate laser welding in a vacuum and in microgravity in the parabolic flight.
Very simply, it's a box, but it's a very strong box, so you can have a vacuum on it. And then there's all kinds of advanced controls in order to be able to move different pieces around inside of there. There's advanced sensors in order to monitor what's happening. And the reason that we're using laser welding is because laser and electron beam welding are the most likely processes in the short term to work for welding and manufacturing in space.
The last time we welded as United States of America was before the ISS time. And the materials that we welded and how exactly the experiment was done, there's little data currently left.
Why we care about welding in space? We need to develop technologies so we can start building more larger structures in space or repair structures that are over there. As part of this, we are working with the Air Force and NASA to understand how the space conditions will affect welding processes.
This is the vacuum chamber that we got from NASA Langley. It's currently rented to us for this project. They were originally manufactured for testing of electron beam welding in a vacuum.
My contribution was making this electrical box, which consisted of designing and developing a schematic for it, and then constructing and designing the house that holds the electrical box.
Critical aspect of this is having visible cameras that are looking at these welds. So we have two different weld cameras here. These see in the near IR/visible spectrum. In addition to that, we have two thermal cameras. These thermal cameras will help us determine the actual thermal history of the weld and the different isothermals as you go away from the weld pool.
And now we are here, we have fully transformed this chamber. It's all fully automatic, state-of-the-art electronics and communication, data acquisition systems. And with that, we are going to be running tomorrow our very first parabolic flight, doing laser welding of aluminum, alloy, stainless steel and titanium alloys. We just came back from a very successful parabolic flight where we were able to test our infrastructure for the first time for real.
The flight itself, no experiment ever goes to plan, and a testament to the student because they adjusted as needed on the fly, and we got 69 out of 70 parabolas of data. We were incredibly happy, and NASA even told us that it's unheard of. Usually a lot of the teams don't get any data on their first attempt.
During the flight, we had a lab view error that could have been a huge problem in missing parabolas, missing welds.
It essentially lost connection due to a turbulence or some kind of flight equipment issue, which we had a quick solution to, but we'll do a further in-depth investigation into how we can solve that.
So one interesting thing that we discovered from this is the importance and problem of deposition of metal vapor when you're welding under a vacuum. If we're trying to do 40 parabolas in a single go without swapping any lenses, now you're starting to deal with a bunch of deposition that's going on your lens, that's now absorbing all of your light that's going through that you're trying to weld with. So we found ways to combat this, but it's been a continuing thing that we're going to continue looking into.
Regarding the actual weld itself, we have to make sure how we prepare the material itself to be welded has to be very consistent. So regarding it, we got the data that we wanted. We know what refinements we need to do according to the equipment, but baseline is our equipment works and we know where to go from now.
That was quite successful. We are now going over the data. We are very excited. All the welds look very good, but we haven't started analysis yet.
I think this project revitalizes welding in general. And the fact that we're able to manufacture or even just assemble in space brings about, new awareness that can be taken further with future research.